Hello and welcome to the All About Pigeons podcast. We have a very special episode for you today, so stick around. Today we have a listener requested episode on color genetics, and we have here with us Drew Lobenstein to talk about that. Drew has been a master judge from the National Pigeon Association. He is a member of the National Pigeon Association Hall of Fame and has received the NPA Lifetime Achievement Award. Drew has been published in at least 5 languages for his work in genetics and has traveled the world to judge and lecture on the subject. Drew, thanks for coming on and talking with us today.
Well, it's a pleasure to be here, Phil. It's especially talking genetics. There's a bunch of us that speak in the genetic groups, and some people think it's an actual foreign language. But we'll try to clear that up today for everybody.
Absolutely. Let's make it simple. Make us all pros at the end of this.
Absolutely. So we love talking to people who are open to hearing some things about pigeons and genetics and what it is that drives that passion that we have for these birds.
So can we talk about your own experiences with genetics, some of the colors and patterns that you've personally been responsible for creating?
There's some basic stuff out there. We in Southern California, we had the great privilege of having a whole bunch of genetic people. We met at Joe Frazier's house out in El Monte once a month. There would be a gathering of genetic nuts, basically, and the conversations would go into all kinds of crazy stuff about genetics. But if you look in Wendell Levi's book, Encyclopedia of Pigeon Breeds, you will see Joe Frazier's dilute checker opal giant homer hen, and whatever page it is in the encyclopedia, it's one of the most beautiful pigeons I've ever laid eyes on. And just to see, well, a person, a human being, a man, a human, could take the genetic characters and put them all in one bird and make something that beautiful. And without Joe Frazier, that bird never would have existed. But here's some basic stuff. In pigeons, there are 3 ground colors, and it doesn't get any more basic than that. There are 3. And the primary colors in pigeon include what they call wild type, which is blue or blue-black. There's ash red, which they call dominant red. If you go to Europe, they will refer to it as dominant red. And the 3rd color in pigeon is brown. And so you can take those 3 colors, the basic colors, blue or blue-black, ash red, and brown, and then the whole rest of the world is modifiers. So there are hundreds, maybe thousands of modifiers out there that you can take these 3 colors and you can just paint the world with them. All the pigeons in the planet will fit into those 3 colors, and somewhere in the mix there will be up to several hundred, maybe I say 1,000, of different things that would modify those 3 colors. The more common thing that everybody will know is that the patterns in each one of those colors can occur. Now, the basic patterns, you're going to have barless, most recessive. That's the lowest on the pattern panel. The one above that one would be bar. So bar is dominant over barless. Barless isn't dominant over anything because there's nothing below it. You would have open checker. Open checker would be dominant over bar and barless. And then the saturated or T-pattern checker, which is a darker checker, and then saturated checker, which is like Jacobins, and those are the checker models. Now you can have that modifier they call spread, and if you put spread on, say, a dark pattern checker, saturated checker, it becomes a black. If you put spread on ash red, it becomes what they call a red straw. And so you can open the wings and you can see lightning factors between at the quills. They go light. You can tell the strawberry is basically an influence on those feathers. And the spread on brown, it just makes it go like olive dark, beautiful spread brown. And then depending on what else is underneath it, you can have those all on the same bird. But you can go spread and bar or spread and checker or spread and saturated checker and produce all kinds of different varieties of things. So whatever combinations are out there. In the middle of this, all of those things that I will call modifiers, there are a bunch of dominant modifiers. There are something called co-dominant modifiers. There are sex-linked modifiers, and then there are what we call autosomal modifiers. The dominant ones, everything comes, whatever that dominates. If you go to the Mendel's law, you go in any of the pieces of work that do numbers on genetics and figure it out. It was like Gregor Mendel who did all his work with sweet peas, and he figured out there was this Mendelian ratio. So if you have dominant traits and recessive traits, and you make them to each other, and then you make the offspring to each other, there is a specific number of chances you get to have the recessive trait reappear. And so it has a 1 in 4 chance if you made, like for instance, I'm doing this right now. I'm doing barless Jacobins and barless fantails. Barless is the lowest one on the scale, patterns anyway. So if you take a barless and you made it to a bar, then those bars that come, all the babies will be bar the first generation. And all of those bars coming from that mating will also carry barless. But you don't know on the next generation, if you raise bars out of those birds, you can't tell whether they're carrying barless or not. You have to like test them. Or if you're really tricky, like Andrew Kearns in, in Virginia, he opened the wing and he can see the bars carrying barless because the patterns go on there, the things that his great eye could pick up. But what I've done, and which is easier, is I would take a barless and made it to a checker, and all of the babies that are checker are carrying barless. And so you have all these checkers carrying barless. And if you make those checkers carrying barless to a bar, well, guess what happens? The bar is dominant over barless, but it's not dominant over checker. So every one of the babies that comes from those checkers carrying barless on a blue bar, every time a bar baby shows up, it's carrying barless. You don't have to test it because you know the dominant recessive trait. So you watch your mathematics. But you can go into 2 generations breeding with that if you know this little trick. And you can produce the birds for skipping a generation without having to take a whole year to test them out to see if they're carrying that genetic project that you're, or that character that you're looking for. In my own lifetime, I was working on sex-linked recessive traits, and that's even more fun because you can put 3 or 4 of those all together, and you can go on for 3 or 4 generations testing without having to test. That's kind of cool. In the program, though, you have like the dominant, some of the dominant genetic stuff. Like a few years, you have a cockbird that's almond. Almond will show up in its normal color, and it carries. Let me go back. Females carry 1 gene for color. They're what we refer to as hemizygous. Hemizygous. In Jacobin pigeons, the males carry 2 genes for color. The male Jacobin, for instance, can carry 1 gene for almond and 1 gene for something else. And so the almond gene, if it hits another almond gene, the baby looks really different. It doesn't look like an almond, it looks white. And they oftentimes are gifted with something called bladder eyes. So a homozygous almond is always a male. There's no way to produce a female homozygous almond. It's just, it can't be done. And they generally have some initial genetic stuff that goes on there with the eyes that manifest themselves. An awful lot of almonds will have cracked eyes or they have issues with eyes already. But 2 almonds together, a male almond, a female almond, and every male that's bred from that has both genes for almond will be white in color, and it'll have maybe some issues with the eyes, sometimes not. They might be blind, they might have bladder eyes, which are these like I don't know, the goldfish, the black moor, where the eyes pop out. They're bigger and they look like bubbles on them. Sometimes that doesn't happen. They just be pure white with a normal looking eye. But for the most part, you can make 2 almonds together, and the likelihood you would raise one of those white males with a bladder eye is like only 1 in 4. So 3 of the 4 chances you're going to have something else, an almond that isn't having any difficulties and is normal and recognizable. One of the other dominant traits is called opal. Opal doesn't look any different when you put it on cots or hens. They look exactly the same. But in opal, dominant opal, there's another characteristic that comes along with that particular modifier, which they refer to as a lethal gene. And so 2 opals are together, an opal cockbird and an opal hen. Those produce, in a homozygous state, if they produce an offspring that is opal and opal, will be a cockbird, has to be opal and opal has to be a cockbird. It also carries that lethal gene within the opal. They generally die in the eggshell. So you look at, have eggs and one's fertile and the other one's not. It could possibly be that the germinating embryo in the egg died, before it ever started to develop. Homozygous opals generally don't live. They don't exist because the lethal gene is there when those 2 get put together. But any opal mated to anything else, 50% of the babies are going to be opal. And you've made an opal hen on anything else. The opal is dominant coming from the hen. So half of the babies will be opal and half not. If you're moving it to something that's not opal, which is probably a better idea. If you're familiar with the whites, whether it be like blue saddle mark racing homers, some of them have white bars. That would be one of the forms of opal generally. Recessive traits come in 2 forms. And I would say, well, let me go back to almond again. If you have an almond hen, all of her sons are going to be almond. If you have an almond cockbird, any color hen, the daughters are going to be almond, normal almond, and the sons are going to be almond with whatever the female carried. So she could be ash red, You can make your kite almond on an as red, and you get these almonds where the flecking is red instead of black or kite. My favorite one is to make an almond cockbird on a brown hen, and I've done that several times. And the babies come out, and you'll see some of the black ticking or kite ticking, and then they have brown flecking in there too. And with the darker brown color, the almond color in there, it's neat. It's like having a rainbow, a little plaster, all kinds of stuff is spoken in there. The best model of that I ever saw was a Bokhara trumpeter that was raised by a guy in Bahrain by the name of Zuhair Haji. Zuhair is a top guy in Bokhara trumpeters. But he was smiling as he handed the bird. We were in India, and we were at one of the best breeders' houses there in India. They were all gathering around and learning about the birds. It was kind of cool. He handed me this bird, and he smiled. He explained what this is. I looked at it and go, "Oh wow, we got a rainbow!" But it was a Bokhara trumpeter. It was almond split to brown, and it was just this beautiful, beautiful pigeon. And there is a tape of that somewhere that just shows me opening the wing of the Bokhara trumpeter, looking at it, looking up and explaining what it was. That can happen. It gets these multiple things. When you add genetic modifiers on things, you can create all sorts of different neat looking stuff.
Yeah, especially with a large bird like that, you have a nice palette to work with. A lot of color can be shown.
Oh, sure. And then the neat part is the whole group, Bob Nolan and I got invited to go to India. So they invited us to go to judge the international show there, Thrissur in southern India. But man, those guys are doing it right. They're all enthusiastic, and Bob and I were the only gray birds in the mix. Everybody else was probably 40 or younger. And boy, they're just doing a storm up there with Jacobins and fantails and powders and croppers and everything. They're really enthusiastic. They got the pigeon clubs going. They're starting to do shows, and they get this amazing awards out. It's pretty cool stuff. But back to my genetic recessive traits. Sex-linked recessive is the next one I would talk about a little bit. Sex-linked recessives are easy to track because the cockbirds could be split for it, and then the hens either are or aren't. So, for instance, there was Abraham Sazi. He lives in New Jersey, but he works out of Pennsylvania. He goes across the river to travel. But he was a native of Bahrain, came to the United States some years ago. But he created a reduced Jacobin. The very first one I ever saw was Dr. Shaji working with Modinas. He had a reduced Modena across it to Jacobin. And with the sex-linked recessive, basically the cockbirds carry it, and they throw daughters that either are or aren't. So the cockbird carrying two genes, one of them is a sex-linked part, and the other one is not. And so when they throw the one that is, whatever it is you're looking for, the sex-linked recessive, the daughters come that way. And the only way to get a cockbird in that color is have the mom the same thing too. So for instance, if you take, let me do it easier. Brown is a sex-linked recessive in pig. It's really easy. Brown, so you have a brown cockbird on a blue hen, for instance. That's sex-linked. All of the daughters from that mating are going to be brown, and all of the sons from that mating are going to be blue, carrying brown. Patterns in there, you can mess with that, add another bunch of stuff in. But the basic tour is that the father throws the genetic character, whatever it is, and then it meets the genetic stuff from the hen. They combine in the sons, but the father overlays, and the daughters always resemble whatever the father threw. And the sons always will carry both of what the father threw and what the mother. So the sons are always a combo because they carry two. And the daughters are always singular. In hemizygous, they only carry one gene per color. So in brown, for instance, you make those brown cockbird on a blue hen, you got brown hens, you got blue cockbirds carrying brown, color pattern in there, add that on, another thing to keep track of when you're doing it. But now those sons carrying brown, mated to a blue, will throw a blue daughter and a brown daughter sometimes. When the blue wild type hits, it's going to be blue. When the brown hits, the daughter's going to be brown. In that same mating with a blue hen and a blue cockbird carrying brown, the sons are going to be 50-50. They're going to catch a blue from the mother, and they either catch a blue from the dad or a brown from the dad. If the brown from the dad throws, the mother's blue overrides it. So those have blue carrying brown, but you don't know who they are. So you raise 4 babies. 2 of them are probably going to be carrying brown, and 2 of them are going to not be carrying brown, and you don't know. But the daughters are either brown or blue. So the sex linkage is always you could tell from the father that daughters will be whatever that sex-linked recessive is that the father is carrying. In Jacobins, for instance, yellow cockbird on the red hen, ash red, ash yellow on an ash red hen, the daughters are all going to be yellow and the sons are all going to be red carrying yellow. Every once in a while, they'll kick out, get that cockbird, that red cockbird carrying yellow on a red hen. Every once in a while, they'll kick out a yellow. Well, the yellow is always a hen. The blue is carrying brown, cockbird carrying brown on a blue hen. They throw a brown, it's going to be a hen. They will reduce cockbird on a blue hen that's not reduced. Any reduced they raise, it's going to be a hen. So these are tracking. That's why it's called sex link, is that those are absolutely dependable.
That's probably the easiest way to determine the sex then of a young pair of birds, if you understand that side of it then.
Yeah, it's absolutely convenient though. It's like, if you're familiar with or can track them, I mean, your mind has, the ability to do two or three things at once. It's really easy to track if you know those patterns and you know the dominant recessive traits. You can do all kinds of extra things with them. Don't have access to that knowledge. They have something, well, what do I get when I make this or that? And they say, well, they just don't know because they don't have the background on it. And I'll tell you, I spend probably an hour or two, sometimes 3 or 4 every day answering questions, some on the phone, some on the internet, some, just face to face. But generally, I just call Ron Davis, my friend in Oklahoma City, calls me this genetic guru. And I always visit with Ron and get calls from John McKeer or Jim Ecker and stuff. And we just have these wonderful visits over that. But it's always, it can always start with, oh, what am I going to get when? Or I raise this saying, how do you explain it? Generally, there's a wide variety of genetic stuff that can happen. Anyway. The straight recessive, now you have sex-linked recessive, which always will key off of the male carrying 2 genes. And he could throw daughters that are whatever that sex-linked recessive is. And the only way you get a son out of those that's the sex-linked recessive is to have the father throw it and the mother be it. And that's the only way. You get a cockbird that's brown or a cockbird that is silver or dilute. You get a cockbird that's yellow or dun or khaki or reduced. They all had to have that same color as the mother. The mother had to be that too. And so that's how that works. But the mother always has to be the recessive trait as well to raise a son, a boy, male in that color. The autosomal recessive now are different in that both the mother and the father have to carry the recessive trait. So, for instance, I will take, pattern is autosomal. A bar to a check, you'll raise a check carrying bar. You raise a cockbird, a check carrying bar, but you also raise hens. Now, it's not related to color, so it's not on the X chromosome of that locus. So the females can carry 2 genes for pattern. So that is kind of challenging. So the female can carry 2, and the male can carry 2. And so you have a male is checker on both sides, and made it to a blue bar hen. All of the babies are going to be checker, all of them. The sons and the daughters are both going to carry barless, a bar. And so you can make 2 bars carrying barless together. And 1 out of 4, there's Mendel working on you again. You got white sweet peas and red sweet peas, or pink sweet peas, or tall sweet peas, to short sweet peas dwarfs. And anyway, you get them all crossed up, the hybrids, those in the middle, those half and half, throw stuff in a specific pattern. They throw one that's completely recessive, one that's completely dominant, and out of 4, you got 2 in the middle that are one of each. So out of 4 babies, you get 1 recessive, 1 dominant, and 2 dominant carrying recessive. That's how the mathematics work on that particular character. So your autosomal recessive then have to be mother and father. The autosomal recessive experience that I have, again, in Jacobins and Fantails, is milky. Milky is pretty cool. It has basically autosomal, and it has to appear in the homozygous state in both the male or the female to be milky. They can carry it, both the male and the female. But if you put 2, say a blue carrying milky hen on a blue carrying milky cockbird, there's a chance, 1 in 4, that you're going to get a milky, and it could be a boy or a girl, because this isn't sex only. So the autosomal stuff, you have to get the gene from both parents, and the baby comes out, and it is generally 2 genetic characters instead of just 1. I think we got it. So we got the dominant characteristics. You got the codominant, which could be indigo or Andalusian, almond, opal, You have straight dominant characteristics, which could be like spread, that would be okay. The sex-linked recessives are things like lemon or extreme dilute, dilute itself. The color intensities, if you have, say, archangels, which come in intense, pale, dilute, and extreme dilute. So if you know Tim Caviglia in Minnesota, Tim has produced lemon or extreme dilute archangels. And this is really cool stuff. If you take a dominant, say a copper black-winged archangel, onto a lemon hen, all of those copper black-winged archangel younglings, the males carry lemon or extreme dilute. And if you put one of those onto a pail, the pail comes out where you can check the sons that are carrying, that are pale, carrying extreme dilute. That's pretty cool. And then you can go with those pigs carrying extreme dilute and put them on a dilute. And the boys that are dilute out of that mating are carrying extreme dilute. So you don't have to test it. You can go 3 generations and never have to go back. You just go full speed ahead on that one. But it's kind of tricky. You have to know how it works. But you play them against each other and the dominance against the recessive. But if you know the patterns and the levels of dominant or recessive, you can play them back and forth across each other and have all kinds of fun producing stuff. Those are part of the things. So you have autosomal recessive, sex-linked recessive, and then pure co-dominant recessive, and then regular dominant recessive, or dominant not recessive. Did I confuse you yet?
Almost. I'm taking notes.
Okay. We tend to lose you. We go and you'll say it once, and anybody who has a background in genetics will go through, oh yeah. We compare notes, we go up and explain. It's like we'll get finished, it's like, hey, too much detail, move on. It's kind of fun. Most people don't want to hear it, but all of a sudden, once in a while, it becomes useful to know that stuff.
Absolutely. Yeah. So that way you're not rolling the dice every time, just a basic understanding, then doing it, and then really getting that knowledge set in stone.
And you watch the thing. I've had fancy pigeons my whole life. You talk to the guys that raise fancy pigeons. There's a whole bunch of genetic people in that mix, and they'll talk genetics. And there's some basic things that we all know. We know that 2 dominant colored pigeons, like 2 Irish reds, for instance, they raise a yellow hen. It's a hen. And there's some basic stuff like that, but they're not too detailed. But anything like if you raise, a dilute out of a pair of intense, it's a hen. Those are kind of common knowledge that you have. If you bred pigeons for a while, that's the way it always is. Those things come up. But in the racing homer group, those guys, they're not into genetics as much as they're into the genetics that produce the best flying bird. So, really are things like, for instance, in the show pigeons, the guys are going to refer to an ash red bar as a mealy, ash red bar as a mealy. You talk to the racing homer guys, they may refer to it as a silver, as a red barred silver. I was like, what? So actually, in the genetic term would be a mealy or a ash red bar, and that would mealy. And the fancy pigeons and the racing homer guys could be a mealy or could be a red bar silver, depending on who you're talking to. But those are, they don't have the working genetics for color that the rest of us do. But they sure do have the working genetics on how to produce a bird that'll get home in a hurry. And I say, if you left that up to me, I'd be in big trouble. So I would definitely not be the one to, produce a racing homer for the homing instinct or the speed to get there. But you want to deal with raising colors, different colored ones? Call me.
So we got listener questions, and you covered the first one. Mason Hoots, he was asking for just a crash course. So I think we got that one covered there.
All right.
Another one was from Jake Kaiser. He said he is looking for information on producing clean tail mark with high quality color and fantails.
Guys that race mark birds, and I raised saddles for a bunch of years and did pretty well with them. The key that comes from markings is that the tail mark and saddle and body mark, those are all markings that are just straight autosomal recessive, you hope. The idea is that they come close. Sometimes they're not marked perfectly. You'll come with say a tail mark with a few white feathers in the tail, or a saddle with too much color in it, say a black saddle in the wings, and it'll have a few tail feathers that are black as well, or sometimes even the whole tail. I think Leon Stevens has the best sense of this one. Leon and I have been friends for years, but he was making saddle fantails early on, and he was working on making the saddles, mating them to solid colors. Now, this will work for tail marks and body marks as well. So what you do is you take a marked bird and you mate it to a self-colored bird, a bird with no markings, so that you don't have to worry about it. the guys early on were making saddles, and they were thinking, well, this splash over here is almost a saddle. Then we made it to that. And it turns out splash is not anywhere near marking. It's just a splash. It doesn't have markings attached to it. And so you would just mess it up and it would be all over the place. If you raise nothing but splashes and you think, oh, what happened to the markings? And Leon, as they discovered that if you made them together, you get saddles most of the time. And if you made a saddle to a self-marked bird, a bird with no markings, other babies can, or maybe they do, maybe they don't have a white feather or here or two, but they will produce perfectly marked saddles out of a command together. That's that one and four thing again. Or if you made a saddle back to a bird carrying saddle, that's another way to advance the birds. You're safer doing it with, a saddle to a bird that's carrying saddle or a bird with tail mark that's carrying tail mark. But the intensity, the color, you have to select for that. And, it's just, you've got to keep the characters that are in there. The things that make the dark color in pigeons, you have something called sooty, which a lot of people, when you see a bar of a sooty, they think it's a checker, but it's not. It's a sooty. And if you look at the sooty feather and you look at a checker feather together, so if you went and you pulled a wing feather out of a racing homer, maybe a blue checker racing homer, and you pull a feather out of the wing shield of maybe a sooty jacobin, and you look at the feathers together, you sort them in hand, look them next to each other. The checker one, if you look at it, it's going to have blue at the tip, or whatever the color. That's what I call T-pattern. So the end of it, blue, and the part of the feather might be black, covering, that might be producing the checker. If you look at the Jacobin feather, if it's sooty, the sooty is going to be on the end of the feather too, as long as, and maybe up into the middle of the feather, and outside and away from the quill as well. And so you can tell sooty from checker just by looking at it. You know that the checker is actually going to have a blue tip on there, and that's why they call them T-pattern checkers. Is that it comes in that way, and it's clean otherwise. Sooty is a mess. It's just it clutters stuff up. It really ruins the color on a blue, but it helps the color on a black or a red. The other one in there would be what they call, between sooty, and then there's another darkening one. I get to remember of it. But the birds with black toenails and they come with black beaks, and that one's called dirty. So there's a genetic character we call dirty, which just makes everything darker. It just goes darker. So they generally have black toenails, dark color blue. Generally the beaks will go black as well. And you make sooty and dirty together, and you add any kind of bronze. Is about, I don't know, I won't say a number, but there's all kinds of numbers of bronzes. The teens are better, maybe 20s or 30s. But you add those kind of things, and those are all darkening factors. Grease quill is another darkening factor. Grease quill you'll see in a lot of the German color pigeons or the field pigeons. So it makes a beautiful dark color with the shine. You go to archangels. Archangels are most likely carrying something called grease quill. And if you open the wings, it's just this beautiful shine. The grease quill produces extra lanolin. And the lanolin is what produces the shine, the red and the green sheen on a pigeon. If you see those, that's the lanolin that's produced by the oil gland. But they also have grease quill, which if you look behind the leg under the hawk feathers, and you can pull them back, you can see feathers in there that are kind of yellow and clumpy around the middle of them. Those are birds with grease quill, and that grease quill makes them darker and shinier. I did that with Jacobins. I produced red and kite. I have two now. I have a red hen and a kite hen that I produced. They're both competitive Jacobins. The grease quill did not appear in Jacobins until I put it in there, as far as I know, except in Europe. It didn't exist here in the U.S. or North America that we know of. The birds are darker and they're shinier. And that's what grease quill did. In addition to the Jacobin Lebanon bronze, it just makes them super dark. But if you're going to raise bar-colored birds, you want the color lighter. Those things you don't want to have in the mix. You don't want sooty and dirty and bronze in your blues and your creams and your mealies, because it just makes them look gunky. But, nice and clean, so you got to clear those out if you want a nice clean color in a bar pattern, in the lighter version. Am I going anywhere that is of use to you?
I think that answers Jake's question. Go here. So Stephen Nusk says, I have a number of ash red pygmy powders that have deteriorating eye color, some very pale. The question is this possibly a genetic mutation, lack of rigid genetic pressure selection by the breeder, or some mutation coming from days of old?
I guess it's just you're going to keep track of it. And, if you want dominant characters with good dark eyes, you have to have birds with dominant good dark eyes. And you just keep going back to them. It would appear, that would be my guess. I'm name it out for sure. But like with the tail marks and the body marks, those are autosomal recessive traits, and they come back, and you just have to, have to keep track of them. You have to keep track of the birds that are carrying it, and you mate them back to birds that are perfectly marked. With the eyes, I'm not as familiar with the eye color now because I haven't focused on that as much, but I do know that I was working with like red-eyed with dragoon, show races, and dragoons have this beautiful dark red eye. I've seen Kuyu Yun show races with this ruby red eye. It's beautiful. You see this blue show racing homer with a beautiful super dark red eye. And I know as soon as you cross into something else, that eye would go lighter. It was not as good as rich unless you made it two of them together or as close to that. Made them together, the eyes would continue to keep that concentration of color. The more you breathe them, and if you're not paying attention to it, the lighter one shows up, and then the lighter one becomes the more frequently appearing individual. And so that just occurs. If you're not selecting for it, don't worry about it, it disappears. Here's a sample of that. You guys, like 50 years ago, 50, 60 years ago, he's thinking about a leghorn, white leghorn chicken. And they might go into an egg cycle. It would produce maybe 20 eggs at a time. And they might hit an egg cycle maybe three times a year. So out of a white leghorn chicken, you might get like 60 eggs. And that was a lot of eggs, years and years ago. And there's a place in Moore Park, California called Egg City. Egg City had a genetic breeding program there. One of them was producing leghorn chickens that laid more eggs. By selecting those chickens that lay more eggs, they were able to produce chickens which now can form and lay an egg in like 18 and a half hours. So you really have a chicken that lays an egg almost every day or more. And that's out of 50, 60 years of selective breeding. They've gone from 60, 70 eggs a year, something like that, to an egg every 19 hours. That's crazy. In the middle of all of that, they didn't pay attention to the attitude. And there's some crazy little chickens that lay a whole bunch of eggs. And so out of the middle of that, it's just a matter of if you're selecting breeding period, particular characteristic. If you focus on just one, other things will disappear or arrive depending on what you're not paying attention to. One of the major master breeders of Jacobins in my friendship circle is Clint Robertson. And he will have different characteristics, but I will mention his name only because there are like 100 different things you have to keep track of when you breed Jacobins. Clint is particularly good at making sure all of them arrive on the same page. And I got to keep track of 10 or 12 things, just like a Chinese juggler throwing balls into the air. The 2 is easy, 3 is harder, 5 is harder, 12 is harder yet. You keep them all in the air, but Clint is one of the few that I know that can keep so many of them, and his attention to detail. Sergio Del Neda was the same. He was really good at that. He had just tremendous roses on his birds. If you go to Jim Ecker's, you see great color and thick manes on his birds. You go to different breeders that would say Bachman. Bachman would always have these they'd be smaller, but they'd be super smooth. You go to Louis Christner's house, and there would be all these beautiful Jacobins, and they all had just super top feather. And like each breeder basically might focus on the better bird, but then there would be 1 or 2 characteristics out of them that you would see, oh, wow, that's particularly that guy's focus. If you go to Ron Davis's, you're going to see birds that always show well. They've got great legs and they're always up in the air. And that's pretty cool stuff. The selective breeding process, when you're selecting for different things, you talk Charles Darwin is the mix. He's the one with all the genetic characteristics that we know about. And he's talking about selective breeding. You select particular characteristics that you breed for, and you just you bring them in and you select on that one thing, like the every 18 hours on the leghorn chickens, or a particular color characteristic, or a particular thing about the feet. You'll have stuff that shows up in the genetics, like webbed toes or crooked beaks or things like that. And then various breeds of pigeons are busy fighting those different things. In my own life, I did a number of experiments with crossing new things into my birds. I discovered a particular characteristic that was really important to the mix. That first cross that you make, like for instance, I had Jacobins, and some years ago, I created an extreme dilute Jacobin. And so I had a relic yellow racing homer, extreme dilute racing homer that came from the original Barkle stock from South Africa. Well, the very first Jacobin I used to mate to that racing homer that carried, or was actually, extreme dilute, was the very best Jacobin hen I own. The best one. I say every single characteristic, she didn't have any flaws that were significant, but great qualities everywhere else. So all of the babies that came from that particular cow lost all the Jacobin qualities, and the daughters were lemon, with a few little pieces of work. They look like the Leonardo that you see in Wendell Levi's book, called Leonardo, with that little crooked thing on the back of its head. The sons were carrying lemon. And so those sons, I put one of them right back on the mom, who was the very best Jacobin I had. And so those sons come back, and they almost have like almost capuchin look to them. They add a little bit more Jacobin, and they still could see the racing Homer. Funny thing with that racing Homer, they have a really neat eye. The eye is beautiful. It's sort of like a false pearl, but has a sort of luster look to it. It's kind of neat. What I discovered in the mix is that eye carried through into generation 4 and 5. And if you look at the lemon Jacobins today, some of them still have that racing Homer eye from the very first cross. That was kind of cool to figure out. The birds that come back from the crosses, if the best bird you own was the first cross, there's no junk to come back when you raise youngsters out of those. So you keep going to the very best birds you have, and then all of a sudden that generation 4, Bob Vincent will refer to it as the explosion. Bob Vincent, our master breeder fantails in Tucson, Arizona. Rob does a lot of work with genetics and fantails as well. But my experience was the same. At about generation 4, all the junk clears out, and you have this explosion that comes back. And sometimes those youngsters are better than the original first bird you used. That's crazy. But Ron Davis, when I was making browns, Ron Davis got birds at generation 4 that produced a hen that was the best opposite sex to the grand champion of the show at the Grand National Show in San Bernardino some years ago. And I'm just thinking, really? So what's that bird? Well, great-grandfather was a Norwich Cropper. I was like, what? So Norwich Cropper, so we got Brown to make Jacobins. John Brown Jacobins. That was kind of fun. Brown didn't exist in Jacobin. Milky Jacobins, that was autosomal. That's the hardest one I ever did. I didn't use the very best fantail to start it. I used the best Jacobin I could, but I used a fantail, soft, sort of soft, milky filled tail feathers, which was the absolute mistake because that kept with the program for 10 years. A lot of people just gave the color up because it wasn't useful. The feather was too soft. But that was my fault going in because I didn't use the best one going to start. Raphael Mace in France was breeding lavender Jacobins down there, milky Jacobins. But those were produced by Jürgen Frey, a German guy, who was involved in producing the barless Jacobins as well. But he used a really hard-feathered milky. And so the babies that came out of that particular cross, I don't give credit to Eugen Frey. He was really a special breeder of pigeons. And I have barless thanks to him and his nephew is Werner Reichel, who's one of the top German breeders of Shields and Jacobins as well. We learned some stuff from this genetic breeding. Like see something that you like and, imagine that you could make the Jacobin in that color or something else with exactly the same thing. It's really cool. But all the genetic stuff, it's all out there, working with the 3 basic colors, and everything else is a modifier, everything. And the modifiers are dominant, recessive, codominant, co-recessive, whatever. You just got your artist palette, and you just look out, and you just say, well, what do I want to put together? I've got all these choices. And so you start picking things out or selecting them out, and you zero in on a characteristic or 2 or 3 or 5 or 20. Go at it and breed some pigeons. And you watch these guys that have these wonderful rollers that fly, and the whole kit rolls at the same time. Well, that didn't happen by accident. Those were all bred that way. You look at Norwich Croppers or any of the Penny's got some beautiful Borber Croppers I've seen the last couple of times. He's just amazing. He got his birds from Justin Robertson, I think, and Rick Burke. But man, those birds perform. They're hard, smooth feather. They blow. They come, they talk to you. They're selected for their attitude, for the size and shape of the globe, for the color, the markings, and the feet and the legs, all the rest of the details of that. But you zero in on those things for your breed, and all kinds of great things happen. I saw a great Texas pioneer at the Youngbird show this summer for the Los Angeles Pigeon Club. John DeCarlo Jr. showed it. And I never held a bird in my hands that felt as massive and as big, double-breasted pigeon. I knew it was definitely a 2-headed pigeon. You couldn't hold it with one hand. It was too big. And it was just a remarkable pigeon. We placed it high. I think it was the second or first bird in the show overall. It's like, man, this characteristics, you select for them. Darwin was there. It was like survival of the fittest was one of his. Natural selection was one of his thoughts. And then selective breeding was the third most important theory that Darwin gave us that we use completely. Survival of the fittest. You put regular common pigeons in a pen with all kinds of other stuff, fantails and Jacobins and Chinese owls and the rest, and just let them interbreed. And 10 years later, you're going to see a bunch of pigeons that look like the homers or the wild type that you started with. It's all going to revert to because that's the strength in that particular species of bird. But the selective breeding will produce all those recessive traits. And if you get the bronze and Modinas, look at those things. They have gifted with color, toy stencil, bronze, Modinas. You see all kinds of stuff with those birds. But the round bodies, those were developed. But, the colors all mutated out and you have individual things with each breed of bird.
And through selective breeding, like you were saying, it's racer guys are doing it for, a different type of genetic that they're looking for. The roller guys getting their birds to do what they do. That's at the core of the pigeon fancy. That's how we got so many different breeds is through these genetic experiments.
You're right. Well, I talk breeding sometimes with my friend Paul Marini. He used to be the manager of the Palmetto Pigeon Plant, where Wendell Levi basically started the place. But they were breeding Carnu, they were breeding other utility kings and utility homers, the crosses of all kinds of things. But the thing they were specifically genetically producing was birds that could have a whole bunch of babies that had a weight somewhere between 8 and 16 ounces, somewhere between 12 and 16, but they would produce as many babies as they could that had this certain range of the weight the babies would weigh cleaned out and dressed out, basically. And I was like, whoa, they have birds that were raising 18 babies a year. Even the pairs, and it was select for that particular characteristic, which was they raised a whole bunch of babies. And so they had this line of birds that was the best in the world at producing squabs to eat. And I was like, whoa. And then you see, like Sergio de Almeida, he's one of the top Jacobin breeders I've ever met in my life. But man, he was just doing all kinds of things with those birds every year. Would produce better and better and better. And his birds had always these perfect roses, always perfect roses. They were big, they were showy, but there were certain characteristics on his birds that were absolutely perfect. And his eye, basically zeroed in on that. And so selectively bred for those. And they always came true. They always bred true to that as well. You get birds of him, you knew they were always going to have good roses.
I wanted to ask, are you going to be able to make it to the NPA Grand National in Oklahoma coming up soon?
My intention is to be at Oklahoma. I do have an engagement, and I'm going to be judging the British Jacobin Society show in Darlington, Great Britain, first weekend of January. And we'll go back from there and hopefully rest up. We'll make it to the national following that, I think.
We'll hope to see you there. If anybody wants to see, Drew does have some YouTube videos. You can just search his name and you can hear him talking on a variety of things on genetics, on Jacobins, on breeding. Really, really good stuff there too. So this has been awesome. This is definitely one of the episodes that you're going to have to listen to a couple times with a pen and pad in your hand and answer your questions as you listen to it.
I do. There's about 3 or 4 videos posted on YouTube. If you just push my name in there, Drew Lobenstein, and there's a lemon #1 and #2. I did a lecture at the Los Angeles Pigeon Club, which Shahid videotaped this several years ago now, but I was taking a look at that thing. There's like 50,000 hits on that thing. I thought, where are there 50,000 people who would watch a video about pigeons? But it was kind of cool. There's one just on basic genetics, and I have different birds and breeds, and I'll show you the birds. And then the Jacobins particularly are focused on one, but the Jacobin lemon #2 is a pretty good discussion about Jacobins and the parts on it, and how you can watch the generations in there too. From generation 1, cross 2, 3, 4, so you get the color, and then you add Jacobin parts to it. It takes about 4 generations to do that. But anything else the same, but yeah, watch the videos. I get a lot of comments about that.
Well, thanks for coming on and sharing your information and your knowledge with us. We really appreciate it.
I feel I appreciate being able to share. If I don't share, a lot of breeders and pigeon guys would, not share any of their secrets. I don't know that these are secret, but if I'm not here, we get the information. Where would you get it if it dies with me? Paul McNorton was a great teacher about pigeons. He lives in me. Every time I go, I'm talking to him all the time because of all the great knowledge he expressed and shared with me when I was a kid growing up. But the pigeon guys out there, visit with them, share your time, and they're just a social group. They're great people here. And we all have this passion for pigeons, which has come from thousands and thousands of years of keeping them. Anyway, thanks, Phil, for the chance to be with you.
Thank you for listening to another episode of the All About Pigeons podcast. Please help the pigeon hobby by telling your fellow club members or other pigeon friends about the podcast, and make sure to leave a good review or at least a 5-star for the podcast wherever you listen. If you have a topic or a person you want to hear more about on the podcast, or if you yourself would like to be a guest, just send an email to allaboutpigeonspodcast@gmail.com. Thanks for listening.